Alright, so this is a video for section 1-4 for Math 1, which is on literal equations and formulas. So to get started, we're going to define for you what literal equations are and what formulas are. And so these things right here are called Frayer Model Vocabulary cards, I guess. So to fill them out, we put the word in the middle. So in the middle, we're going to write literal equation. And there's 4 parts, as you can see. There's a definition, characteristics, examples, and non-examples. So a literal equation, let's define it, is an equation that involves two or more variables. So let's give an example of a literal equation. Something like this: 2x plus 3y equals 9. You can see that there are 2 variables. There's an x and there's a y. Now, in an equation like this, we cannot solve for just one number for each. I can't tell you what x equals and y equals, because it could be more than one thing. It could be lots of things that would work for both. What we do with literal equations, we're going to write this in the characteristics section, is we can rewrite them using tools we know to solve equations, because they're still equations. And that's usually what we're going to need to do. We're going to rewrite them, and we're going to use the tools like distribution, combining like terms, moving things from one side to the other, undoing operations, that kind of stuff. We can rewrite them using those tools. Okay? A non-example. Why is that not a literal equation? Because it's not an equation, it's an expression. It doesn't have an equal sign. Okay, I'll give you another one. This is not a literal equation because it doesn't have 2 or more variables. We have the same variable x being repeated twice. There's an x and an x, so this is not literal. And it doesn't have to just be x and y. It could be anything. It could be 1/2 m plus 3n equals q. There's the one with 3 variables. Okay, now the second definition that we're going to put in here is a formula. Formula is defined as an equation that states a relationship among quantities. Now, an important characteristic of a formula is it is a special type of literal equation. Because it is going to have more than one variable pretty much all of the time. So some formulas you may know are like area formulas. Area equals base times height. Or maybe you know the formula for distance equals rate over time. So we see we have more than one variable going on in a lot of these. Okay? So non-examples, you can imagine 2x plus 3y is equal to 9. We had it as an example as a literal equation, but it's not an example as a formula because it's just the x and the y don't mean anything. We're not finding anything. We're not looking at a relationship among the quantities. So below here, this is from your book, but it's a very important part of your book. It's a chart that shows lots of really commonly used formulas. Okay, so let's look at some of these formulas. We have a perimeter of a rectangle. Okay, we've got 3 variables going on here, P, L, and W. Okay, now P in this case stands for perimeter. L in this case stands for length. So perimeter, we've got length, and we've got width. So you would plug in the width here for the W and the L here, and the result would be the perimeter. Then we have the circumference of a circle. So we've got the circumference of a circle is kind of like perimeter, but for a circle. So C is circumference. We have radius. Gonna run out of colors real quick. I'll just have to repeat it. R is the radius. Pi is a number, right? Pi is approximately 3.14. It's not a variable, but it is a constant. Okay, and so you can see the rest of these formulas. These are some commonly used formulas. And each of the variables are described here. Now, depending on the formula, sometimes you're going to get the same letter used in different ways in different formulas. So you need to be careful to pay attention to what kind of formula it is and what the variables stand for in that formula.